Digitization, M2M connectivity, artificial intelligence, 3D printing, and virtual reality. Humanity stands on the verge of a new technological revolution, the fourth industrial, as is customary to call it. It will radically change the way people live, work, and interact. In a special program, Digital Kazakhstan, we will tell about what steps are being made in this direction in the Republic and what has already been achieved thanks to the adoption of new technologies. And in today's release, we'll talk about the development of the 3D industry. It is possible to print almost everything on a 3D printer, from small household products to residential houses. Culinary 3D printers create gourmet delicacies. Automobile concerns produce cars that are completely assembled of 3D models. And fashion designers work on clothes fabrication, jewelry, and other polymer materials. This 3D printing boom began in 2014 around the world and was associated with the expiration of patents for laser sintering technology used for the production of metal and plastic products. Technology was invented in the 80s of the 20th century, but was used only on production scale. At that time, only 2 companies in the world had the right to produce these devices. However, 3 years ago, there was a real revolution in the market and democratization of 3D printing. Thousands of models of printers have appeared which everyone could buy. An entrepreneur, not a single jeweler will make this size, but this machine will do it. Oleg Lobach, an engineer like millions of other enthusiasts like him around the world, was waiting for the launch of sales of personal 3D printers as the most important event in life. And as soon as the hour struck in August 2014, he bought his first 3D printing device. And he did not lose it for 3 years. This Kazakhstani company took a serious position on the market, developing production to the full cycle. Services include 3D modeling, scanning, and direct printing of products. As a result, the figure is cleaned, treated by a special solution for making brilliance. Now it will go to an oven and will be dried up. There is a great variety of materials stand-up for 3D printing. In addition to the usual plastic, with the help of these devices, it is possible to make rubberware, products from nylon, photopolymers, gypsum, ceramics, and even wood. For example, this figure is 40% composed of wooden crumb. The orders are also very diverse. The price and speed of production are much more attractive than traditional methods of production. Using a 3D scanner, we scanned, received a 3D model, and then we prepare for further reproduction already here in Kazakhstan. Here is this thing. It is a nozzle on a tooth of an excavator. It costs $2,000. The produced one by us will cost 100,000 tenge. The most frequent clients of the company are people who cannot find details of consumer electronics or car accessories on the market. For example, I use such things for a car that are either out of production or very expensive. Then this is the only way out of such a replacement, because it's impossible to get another one anywhere. That is, it is not simply produced even in China. The process itself is somewhat similar to image printing on an office printer, but in the first case, one coat of paint is applied, and the 3D printer adds more and more material, which is laid down in layers. The print parameters are set: fill settings, thickness of a layer, and the choice of plastic. Roman Shavliv's profession is quite new but rapidly gaining popularity. He's a 3D printing operator. His job is to maintain devices, control the production process, and check the digital models for defects occurrence. If there is an error, then we send them back to the client, or we offer a service to modify the models. That is, the model does not reach the print with errors. After the model preparation, the program is opening. It is a virtual printer platform. The dimensions are outlined there, and you cannot take a place beyond it. Then, using an SD card, in the case of first-generation printers, and Wi-Fi, the information is transferred to a 3D printer on the latest models, and the printing is started. Having worked only a couple of months at this position, Roman is thinking about a promotion, and it is not about monotony of work, but about growing competition. In America, they are teaching students for 3D printing operators over the period of 3 days now, and therefore the fact that anyone can become a 3D printing operator now, so we even need to develop in this area, 3D visualization and 3D modeling. In Kazakhstan, the master's program for 3D specialization, visualization, and animation has been operating for 5 years already. During this time, about 50 graduates had found work in domestic companies, in film and television content production. But the field of visual effects application goes far beyond the limits of the media.
Animation and VFX is one of the most popular and fastest growing industry these days. And it gives a massive opportunities to the students. Students can go for e-learning to make e-learning lessons. They can do that. They can go for medical industry. They can go for, we are making some simulators for oil field.
3D cranioplasty and 3D stereolithography allow us to cover such large, extensive defects of skull vault. Kazakhstani doctors are actively developing 3D technologies. In particular, for the last year, Almaty neurosurgeons conducted several operations with the use of gypsum polymeric implants printed on a 3D printer. The procedure does not take much time and guarantees a 100% result, both in terms of aesthetics and in the medical aspect. In addition, thanks to preoperative training, the patient's period of anesthesia and recovery from surgery are reduced. The patients who have large complex skull defects come to us, do computer tomography of the brain. Our CT, MRT doctors record the data of this study on a CD and bring it to us. In the future, we process these files, and on the basis of these files, we make a 3D implant printed on a 3D printer.
На основе этих файлов изготовляем 3D-имплант, распечатанный на 3D-принтере.
As of today, based on the proposed methodology and successful conducted operations, surgeons are negotiating on inclusion of this method to the list of high-tech services within the guaranteed scope of public medical care. Our people should not travel anywhere beyond the Republic to distant countries. It is both materially and morally difficult, but here it is possible to do it in the conditions of our clinic with the application of these techniques. A person will be at home and he will feel comfortable both in the language barrier, both in the moral barrier, and in the family communication. Ayman Moldabekova herself experienced the possibility of 3D printing, but already in the field of orthopedics. Ayman became one of the first Kazakhs who replaced the traditional arm prosthesis with the help of a 3D printer. On the first day, I was used to it, just needed to work out the muscles. In fact, I'm working with my active part of the wrist. I fasten the wrist, and the wrist fastens itself, so it is the way it works. Ayman's prosthesis was printed in the studio. Initially, the company was engaged in the manufacture of architectural models and the production of plastic products. Then, thanks to state support, the guys were able to expand their business. The arm prosthesis costed Ayman 85,000 tenge, which is the next cheaper order than foreign analogs. The prosthesis consists entirely of plastic. Strings or nylon threads are also used, but we use strings as well. We have a mechanical prosthesis whose action is due to the tightness and unfastening. That is, the strings return the fingers back better to their original position. The prosthesis is much lighter than its rubber fellow. On average, it weighs 200 to 250 grams. The model consists of 7 parts. Each element is printed in about 8 to 9 hours. In general, it took about a month to make a prosthesis, including design development, fitting, and printing details. The incident with Ayman got on the mass media, and in the company, the orders had been appeared in great numbers for the production of arm prosthesis and leg braces from all over Kazakhstan. Developers confess that for the present, laboratory capacity does not allow the production of prosthesis in bulk. A serial production will appear in the near future. If you analyze the needs of Kazakh consumers, then the first place in terms of popularity among 3D products will be the segment of automobile components and details of consumer electronics. Next in the ranking is jewelry and designer products, namely exclusive inventions that cannot be found in the market. Quite a large part of orders in 3D studios comes from architects, sculptors, and inventors. Therefore, they are allocated to a separate segment, and a third place is given to them. Souvenir products and small-scale production are usually ordered on the eve of the holidays, and in the context of the year, they demonstrate quite impressive figures, the fourth place in the rating. Customers of metal industry sphere and machine construction are still few, but their contracts are regular and quite large in volumes. The fifth line. The spheres of medicine and education are still on the sixth place, but they promise to increase the potential in the near future. The remaining 15% contain one-time recurrence of the customers from other sectors of the economy. There is nothing surprising that 3D printing had found a use in the cinema. The technology provides the fastest and most realistic reproduction of scenery, property, scale model of varying complexity buildings, and even body parts. This happened in the work on the scenario Kazakh Khanat, Diamond Sword, which came out in early 2017. According to the idea of the authors, the warrior's head was cut off in one of the battle scenes. The scale model was to be produced in a short time and with maximum precision. The decorators cope with the task thanks to 3D scanning and printing. The model was made in one day, and the filigree similarity of the gypsum copy and the actor made the scene truly documentary. 3D model can show both stone textures and terrain features. The same story, but in the archaeological plane. Again, 3D technology. For 5 years now, the staff of the archaeological expertise, laboratory and large brushes and picks with modern equipment, quadcopters, 3D scanner and virtual reality capabilities. The main advantage of the methods is that the artifacts found during the excavation can be viewed not by 10 people who are on site, but by anyone. The experts post 3D versions of findings into open access, where scientists from all over the world can work with a virtual copy of the object as with the original. A successful example of such collaboration is the work on the project Christianity in Kazakhstan as part of excavations of the Talgar fortress, which was included in the UNESCO World Heritage List. Found during the works, the Nestorian letters were deciphered on tombstones by American archaeologists who used only digital versions of artifacts. It is impossible to ignore the total penetration of the 3D industry into traditional spheres of economy and science. Therefore, year by year, there are those who wish to study the promising industry more and more. For example, Rustam Asilkhan, he graduated from the University of IT Specialty. It would also seem a popular profession, but choosing a master's degree, Rustam chose 3D visual effects. Basics of programming now help in the creative industry. Programmer's education helps me much in this activity. That is, we work on Maya, Autodesk program, 3D modeling program. Thanks to programming, I can animate my characters and also create 3D models, not manually, but with coding. Purchased at this university, printers are created by domestic specialists. There are already about a dozen manufacturers of devices on the market. Price varies from inexpensive, by 20 to 30% lower than imported ones, to substantial prices. In this case, a warranty and service maintenance are included to the printer cost. 3 years ago, Oleg Labach was looking for customers by himself, talked about 3D industry at specialized events, offered services to his friends and acquaintances, and advertised on the internet. As of today, the entrepreneur notes not only the number of orders are growing in geometric progression, but also qualitative changes in the portrait of his average buyer. People do not just say, "Print it for me," but they are interested about what material will be printed, which material suits mostly in their case. People will begin to study, and with each passing month, they come more and more often. Considering such large-scale transformations as well as expert forecasts, it can be considered that in 5 years, 3D printing will replace small-scale production. 3D studios will appear everywhere, where there are even 1,000 potential buyers. And the prime cost of consumables will be steadily declining, both in the field of polymers and metal parts. There are grounds for believing that Kazakhstan will occupy a solid niche in the field of 3D modeling and software development for printing.